Hello. In our previous video, we have seen linear regression mathematically. Let's do it practically. In this video, we shall also see error metrics such as MSE, MAE, Rmse. These are used to evaluate and report performance of regression model. So let's begin. Initially, we need to import the three libraries. NumPy is a scientific package that allows many high performance operations, mathematical operations on single as well as multi-dimensional array. Matplotlib.pyplot is used for data visualization and graphical plotting. Pandas is used for performing data manipulation and analysis in Python. So let's run the cell. Further, let's read the CSV file into a data frame. Let me call the data frame as dataset. Dataset equals to pd.read_csv, and in brackets I need to pass the path for the file that I shall copy from over here and paste it. Run the cell. Here my data frame is ready. Let us check the value of our data frame using dataframe.head. So here we can see the contents of our data frame, but only 5 rows are displayed. What if I want to see 10 different rows? So I need to pass 10 as the parameter over here. So here I can see 10 different rows of my dataset. Using dataset.info, I can see the precise information of my data frame. I can check in my dataset that I have two columns, years of experience and salary, where salary is a dependent variable. So I shall copy my dependent variable into Y, and years of experience, which is my independent variable, I shall place it into the X. Okay, so X equals to data frame dot ilog. Okay, my first colon says that consider all the rows, and second parameter says that take all the columns except the last column. Here I run, and this is my X. Further, Y equals to dataset dot ilog. First parameter says that take all the rows, and second parameter says that take last column. Okay, so here I can check the value of my Y. So X holds first column, that is years of experience, and Y holds second column, that is salary. So we have separated data into X and Y, but our Y is dispersed into a larger range. So let us reduce the range for both X and Y. Let's divide it by 255. So here you can check the value of X now. Similarly, let us reduce the range for Y by dividing it by same value 255 and check the range for Y. So range for X and Y is reduced. Okay. Further, now our X and Y are completely ready. It's time to split the data. So sklearn library, that is scikit-learn library, is used for the same. Scikit-learn is mostly used in machine learning for classification, regression, clustering and all, right? So from sklearn dot model selection, import train underscore test underscore split. So let's import train underscore test underscore split. It is used to split our data set into train and test set. Okay, so if you will look at our data set, this is our data set which has 30 rows, right? So now what we shall do is we shall split our data set into two parts, where the first part, that is train set, shall have 70% of the data, and test set shall have 30% of the data, that is 9 rows shall be placed into my test set. Okay, so let us split. After I split, I get 4 things: X underscore train. Okay, the next one is X underscore test, then Y underscore train and Y underscore test, which equals to, let's call the function train underscore test underscore split, and let's pass the parameters for the same. First parameter is x, second one is y, third one is test underscore size, right? Because I want to split it into 70-30 pattern, right? So here I shall pass 0.33, okay, and I shall also pass one more parameter, that is random underscore state, which equals to 0. Now what's the use of random underscore state? If we don't mention random underscore state in our code, then whenever code is executed, a new random value is generated by it. Train and test data sets would have different value each time. Splitting of train and test set will vary. But if we have a particular value for random state, every time result will be the same value shall be placed into train and test data sets. That is, splitting between train and test data set won't vary. Okay, so it's a good practice to include random state. So after running this line, what it shall do is my data set should be splitted into 4 different parts: x train, x test, y train and y test, where the train shall have 70% of the data and test shall have 30% of data, that is 9 rows in test and 21 rows in train, as we have already seen. So our splitting is done. Further, let us train the model. In order to train the model, again I shall be using scikit-learn library. So from sklearn dot linear model, okay, import linear regression. Okay. So further, regressor. So this is the name of my regressor for the function linear regression. Okay. So the model learns the correlation and learns how to predict the dependent data from the independent variables. Okay. Let's go for fit. So we have regressor dot fit. Now I shall fit my train data. Okay, so what do I have in my train data? X underscore train, comma, y underscore train. Okay, so this statement shall fit our model to training data. Okay, actually it produces the linear equation for the data. So now our model is ready. Okay, x train and y train is already fitted, that is, our model is trained with respect to train data. Okay, now it's time for testing, okay, or predicting. So the output what I shall get is, I call it as y underscore pred equal to regressor dot predict, and I shall pass my x underscore test. Actually, I already have y underscore test corresponding to this x test data. Okay, but I'm not using that y test data. Instead, I'm predicting y pred data using my model. Okay, so let's predict it. We can check the values of y pred. So these are the values which are predicted by our model. Okay, further, let us plot the data. So this is used to plot the data. Plot dot scatter. Okay, x train, y train, we are passing our train data and we are saying that our point should have red color. So further, in the next statement, we are plotting the regression line using blue color. We are given the title for our model, x labeled as years of experience and y labeled as salaries. Let us run the cell. So here you can see your data is plotted. Further, let us plot our test data. So here we have plotted our test data. Let's run it. This is the plot for our test data. You can check total 9 values are plotted, as our test data consists 9 values in this data set. Okay. Now after plotting the data, let us run the code if a single or unseen value for test data is given. In that case, I have suppose x test 1 equals to 0.05 8. For example, I have this particular data. Okay. Now let me run my program. I shall call it as ypred1 equals to regressor dot predict, and I shall pass x underscore test1. Let's run it and let's check the value for y underscore pred1. Oh, there's certain error. Sorry, it's ypred1. It's ypred1. Okay. Here we get the value. Okay. Further, let us move to mean squared error, MSE, root MSE and all. Okay. So, in order to check the value of MSE, root MSE and all, first of all, let us check what do we mean by MSE. Okay. What is this MSE? MSE stands for mean square error. Okay. Now, whenever I talk about error, fine, wherever I talk about error, how shall I denote my error? Let me write down in short over here. Error equals to y, that is my actual value, minus y hat. Okay. So this is my error. So talking about mean square error, initially I'll take error. Okay. What is my error? Y minus y hat. Next, I need to take it square. So here I take it square. Next, I need to take its mean. Okay. So for mean, I need to take summation where I goes from 1 to n, and this is the summation, and further I need to divide it by total number of values, that is n. Okay. So this is nothing but formula for mean square error. It's very simple. As I said, error is nothing but actual value minus my predicted value. So I shall take actual value minus predicted value as a part of error. Next, take its square. So for that reason we have squared it. And third is take its mean. For mean I need to take its summation and divide it by n. This is mean square error. Further, second formula with us is MAE. Okay, MAE. Talking about MAE, again I need to take error. So when I talk about error, it is y minus y hat. Right? And I need to take absolute value of this error. Instead of taking the square, I need to take the absolute value. And further again, I need to take the mean. For mean, I shall go for I goes from 1 to n, okay, divided by n. So this is the formula for mean absolute error. Okay, it's so simple. The third one is RMSE. RMSE. So root mean square error. So very simple, what I need to do is I just need to take the under root of mean square error. That's it. Okay, sometimes the value of MSE is very large, so we can go for RMSE, which is nothing but square root of MSE. Now what about values of MSE, MAE and RMSE? You know, these values lies between 0 to infinity. Means all these three values could be any number between 0 to infinity. It can be different for different models. And smaller value means the model is better. Okay. Smaller value means our model is better. So let's see it practically. So as we've seen, the theory for MSE, MAE and RMSE. Okay. Let us do its use, right? Again, I need to import them from scikit-learn library. These are metrics, right? So from sklearn.metrics import, right? What metrics do I need? So I need mean squared error. Okay, so it is mean underscore squared error. Okay, then I'll also need mean absolute error. So let me import that too. Okay, mean absolute error. Fine. 1 second, it is not imported. Let me do it again. Mean absolute error. Fine. So I shall import both the errors over here, metrics over here. Okay. Further, let us compute mean squared error. Mean underscore squared error. Okay. mean squared error, and I need to pass my y underscore test, which is my actual value, comma y underscore pred, which is my predicted value, and let us run it. Okay. Further, so this is my value for the MSE. Further, let me also find out its root mean squared value. Okay. So what I shall do is I shall copy the same thing. Okay, and one more parameter I shall pass over there, and the parameter is squared equal to false. So when I say squared equal to false, okay, comma, okay, it will give me root mean squared error. Okay, fine. So in this way we have computed root mean squared error. Now if we wish to do the same thing, okay, let me extend my this, as I shall also take mean absolute error. We have already taken. Okay, I'm sorry. Let us do one thing. Let us do this mathematically. Okay, so for that I shall need import math function. Then MSE equals to np dot square. Here I'm computing my MSE value. Instead of using the function, I'm doing it by using np, okay, numpy square. And what are my two parameters for it? Sorry, square I've already taken. So after taking the square, next I need to subtract. What are my two parameters for subtraction? Y underscore test, that is my actual value, and the second value is y underscore predict. And further I also need to take mean of these values, so I shall pass mean over here. So this function shall compute MSE for me, and if you will check MSE computed by this function and this is almost the same. Okay, it is the same. And what about root mean square error, which equals to math dot sqrt, and I need to pass MSE over there. Okay, so I get the value for Rmse. So you can check both values are 17.98. Okay, both the ways we got the same value. Okay, let us also find out the absolute error for the same. So for finding the absolute error, we have already imported absolute error, right? So mean absolute error, again I need to pass the same parameters, that is y underscore test and y underscore pred. Okay, let us find out the absolute error for it. Here we can see the absolute error. Then we can also find out this absolute error mathematically. Okay, let me do it and show. MAE, okay, suppose I want to find equal to np dot mean. Okay, and what shall I pass over here is absolute value, absolute for y underscore test minus y underscore pred. So this shall find me MAE. Okay, let us check what output did we get. MAE, again we should get 13.43. yes, we get the same value. Okay, so we have found the absolute error by both the methods. Okay, finally let us jot down R2 square. Okay, R2 score we have already studied, like in our previous video we have seen theory mathematics behind this R2 score, right? So let us import it. Again it is matrix. So from sklearn.matrix import R2 square, R2 underscore score. Okay, and let us use the score. So I want to find R2 underscore score. Okay, I need to pass for which values do I need to find the score. So it is y underscore test, and my second value is y underscore pred. Okay, so let us run it and check the value for our R2 score. It is 0.97. Okay, so the best possible score for R2 is 1, which is obtained when predicted values are same as actual values. Okay, so it should be closer to 1. Fine. Range for R2 score is 0 to 1 and it should be close to 1. And whereas range for MSE, MAE, Rmse is 0 to infinity and it should be closer to 0. Okay. Thank you for now.